So welcome to the lesson. So this lesson is called standing waves. We're gonna have to investigate whether or not these waves are actually standing. These are the lab procedures and lab setup. This is the tuning forks, which by all means, when you vibrate it against the surface, it will be vibrating, which will generate the waves right here. This is the actual strength process over the pulley that is attached to a mass of M. Same thing. The only differences are how many waves there are. So we're gonna have to actually learn how to determine how many waves there are, okay? So, and explain why this wave is called standing wave. So let's look at second experiment first. When you vibrate tuning fork, the wave actually generates like this. You will see it is up and down. When it reaches this point right here, this is called one wavelength. Go right here, you complete another cycle, which is called another wave. So this one itself has actually two wavelengths. This is the first one. This is the first one. It starts from here, it goes all the way up to its positions. You go back to the original position. So basically, one wave is one full cycle. Two full cycles, and this is the length. So how long is the string? It's 1.2 meter. And how many waves there are? Two. This is where this term came from. As you can see right here, you see the L that I have, right? That's the length of the string is equal to two wavelengths. And when I rearrange to figure out what wavelength is, I divide both sides by 2. That makes this wavelength is equal to length divided by 2. And for example, I'm just gonna go ahead and do it and write that as an experiment 2, right? So based on experimental 2, so your wavelength should be L divided by 2. So the length is 1.2 divided by 2. That's actually 0.6 meter. That's how long the wave is for this experiment. And also, so you come here, I'm going to talk about the experimental 2 again. Determined speed of the wave along the string. We come back to this term. Velocity is equal to frequency times wavelength. These are the terms. Velocity, frequency. By all means, frequency is this one. This is the unit of frequency, which is called hertz. Wavelength, meter. Velocity, meter per second. Because this, by the way, is actually called that, or 1/second. So let's go back to the equation. It's equal to frequency times wavelength. So look back at the questions. Okay, this is called standing wave because you can see the wave. You can actually see like this also in the real experiment. To determine standing wave, one end of the string is attached to a tuning fork, just like what you see right here, with a frequency of 120 hertz. That's what we need to know. It's 120 hertz. So frequency is 120 multiplied by your wavelength, which is 0.6. So these are the answer for the velocity. So now let's go back and look back at the first experiment to determine whether or not how many wavelengths there are. Use this one as a template. So I'm just gonna go ahead and rewrite the term where length, which is the whole thing, which is the same thing, which is 120 meter, right? And by all means, it only completed like this. This is only one circle, so the L is equal to wavelength. So basically, wavelength is equal to L. So experimental 1. Wavelength is equal to L is equal to 120 meters. Okay, that's your wavelength, which is a little bit longer as you can see. This one. Velocity is the frequency multiplied by wavelength. just assume that the frequency is the same for this case only. The number could change based on what's given. So right here. So these are your velocity. I hope this helped.